So continuing from in our creating a software solution series, we've gotten to the point where we're going to talk about designing a database. And although the primary reason to build a database for an application is to store and retrieve data, one of the sort of the 1B, if that's your 1A, your 1B is that you want it to be able to be maintainable and scalable and stable as well. So to catch up a little bit, we started out with a problem that we wanted to solve. The problem in the case that we're using as our example for this series of presentations is a little goal tracking application. It's an application will allow us to enter some goals into a system, and this would be annual, quarterly, monthly, and obviously, essentially the hope is that you would put yearly goals in, and then as you come to each quarter, you'll be able to drill down into those to generate from those your quarterly goals. From those you generate down and you do your monthly goals, and then maybe you get down to weekly goals based on that. So that's the general gist of the problem we're going to try to solve here, and the thing that we're building towards. Early on, we built some requirements and some use cases. We talked about how people are going to use this system and who the primary users are, which was very small. It's really just the person setting their goals, and maybe there's somebody that's helping them be held accountable to them. So you have a little bit of reporting. We created a clickable demo. We put together some very simple wireframes, nice is a strong word to use, but we put together a little interface to allow people to talk about what we're building our way towards, and to give ourselves an idea of how this thing is going to work. So we've got some basic data entry, some basic reporting, put together, like a header and footer and some of those kind of things, and created put together a little clickable demo so that we've got something that's not really, it's flow, but not really functional. And then we took that and then we started working on the user experience. We started talking a little bit more about how navigation was going to work and what kind of messages are we going to use and how we're going to display those messages, and what's the sort of general look and feel of the application. Is it going to be responsive? Is it going to be mobile friendly? Is it going to be more desktop? Is it going to be allow that design to flow, or is it going to be something that's much more rigid, so that you have like a preferred viewing resolution? So now it's time for our next step. We're going to start with we're going to start implementing really at this point. We sort of started implementation when we worked on the user experience. That definitely would be typically what's part of implementation, but I like to think of that really more as leave that as more a design phase kind of thing, because it's very flexible. It's one of those things that as you're building that user experience, you're getting some feedback, you're doing some testing of it. Yeah, you're putting a little bit of code together, but really you're leaving it flexible so that the design can be adjusted as you get down the road into implementing some of the other pieces. Because at that point you may be, maybe you're missing a use case, maybe you're missing an actor, maybe there's a few things that you haven't stabilized yet. If you're using waterfall model, you're probably already stable. If you're the more popular these days agile approach, then it's probably not. It's going to change. I mean, agile by its mere nature, the way we've set everything up with those processes, is that it's built for change. Sometimes as we get into implementation, sometimes you're going to start from the front end and work your way back, and sometimes you start from the back end and work your way forward. And by that I mean sometimes you start with the interface, and we've sort of done that. We've got a user experience, we've got a clickable demo, so we've really started with the front end. We've put some of those pieces together. We've said these are the flows, these are the data items we want to capture. This is sort of how it's going to look, and then from there you put something behind that manipulates that data, and then something behind that stores the data. Sometimes you start from the back, where you say, well, really, it's all about the data. So I'm going to design all the data that I need to capture and how it needs to move. And then on top of that, I've built some business logic and some rules around that data. And then eventually I'm displaying that out. And there's arguments either direction. we're actually in this approach, we're going to sort of go both. We're going to do the front end, which we've sort of talked about, like I said. Now we're going to go to the back end, and then we're going to essentially sort of meet in the middle. And that's not for any particular reason other than it's just worked well in the way we've presented it. I think there are definitely, and it's outside of the scope of what I want to cover in here, but at some other point, I think we will come back and spend a little bit more time on the front end versus back end decision, where you would start from. And what I've seen in my experience, certain projects that are more suitable to one approach or the other, and it's really by suitable, depending on what you're doing. In some cases, starting from the front end is going to address your risky items, the unknown sooner. In some cases, the back end is going to address them sooner. And actually, there's a few that you don't really start from the middle, but in some cases you do. There may be like a proof of concept or something like that. There are definitely some situations where it's really those business rules, it's the logic. That's really the riskiest part, and you essentially have to do a proof of concept at that point to be able to get that middle tier proven out enough, and then you pick a front or a back end that you're going to integrate it with. In our case, our focus for this whole project is really the data that we want to capture and report on. So also, along with the flow, this application is fairly suitable for it. We're not selling, in the idea of this being a commercial application, we would not really be selling it as much on the interface as much as we would be selling it on, this is the kind of data you're capturing and this is how it's going to be, how to manipulate that data, because there's only so many ways you can present goals and achieving those goals, and and reports and analytics around it. So it's really going to come down to the data and how we manipulate that data and relate that data. So the application, as we've talked about, it's all about goal tracking and reporting. That makes the data itself, the data about the properties of a goal, the attributes of a goal, and the data around that allows you to report on it. That's it. I mean, that's really the biggest key. There's sort of a secondary, there's users and they register and they have to be able to access their data, and you have to keep their data separate and accessible by them. But really the big thing is going to be the goals, whether they're annual, quarterly, or whatever. But at the end of the day, it simplifies down to you have goals and the work done on them as your primary data. It's critical to the usefulness of this project to be able to store and retrieve the data. That next bullet point, it's pretty obvious. If you go and spend some time entering in all of your goals, and you can't get them back out, or they don't come out correct, then it's useless. It's like, I'm not sending this in so that some server somewhere can process this information. I'm putting this information in so that I can log what I want to do, log work against it, and then go back and look at how I did. And this is again flowed really well from a clickable demo, which we talked about in the clickable demo section in that presentation, is that once you've built that flow and that basic interface, putting the data into that becomes a good second step. You don't have to necessarily manipulate it. Basically, a nice second step is, you start with the first step of create a clickable demo. So you've got some forms and things like that. And in the next step, you have the ability to save and retrieve data so that those forms that you built in the demo now can look a little bit real, and that's in quotes, for lack of a better term. So it's things like, I can have a clickable demo page. It is a registration page, and I can enter some data and I can click, let's say, register. And then it takes me to a home page that shows some of that data that I just entered in the registration page. So now I can see a little bit more how that data flows and play around with it. So this becomes a great next step. Now the data, the source, and we'll talk a little about this a little further as we get further into this presentation, the data that we're going to work with, it comes from use cases, not from the interfaces that we built. So that clickable demo, although that may help us with some ideas on data, really our source for figuring out what kind of data we're going to work with needs to come from our use cases, because that's really what matters. Is it's what is it in each of those user stories, in each of those use cases, what kind of stuff has to be captured, what has to be done to it, and what kind of stuff has to be, shown back, displayed back to the user, or, if you integrate with another system, sent out to other systems. So let's start with I'm going to start with like an overview of databases and in general, just because it'll give us a little bit of some terms to talk about, and also just make sure we've got, we all have an idea of what we're talking about here. We're on the same page. So there's really just a few key concepts and goals of any database. You want to be able to store data, you want to be able to retrieve data, and then usually you want to be able to relate the data as well. Because if you're just storing data, it's really, in some cases that does happen, but it's basically, then it's just a document, like a Word document that you've written. Technically, I guess you could say that is a database of a sense, because you've stored that data and you're ready to go with it. You can go retrieve it back. You can write your Word document. You can save it. You can come back later. You can work on it. You can add to it. You can do some stuff with that data. Now, database tends to be a little more, it tends to be structured. There are document databases and things like that. And if you want to get picky of, the file system on your computer is a database. It is the ability to store and retrieve documents. What we're talking about here is much more is when it's the individual pieces of data are important. So in your document, in your Word document, you do have like a title and section headers and sections and some stuff like that, but you really they don't make sense on their own, nor do you care about them on their own ever, really. I mean, if you're doing something like mail merge or something like that, then there's some of that stuff becomes important, because you want to be able to place, a name in the right place or pull a name out of the right place. But with a database, the data is much more important. So it's things like, if you think of an address, all of those bits of information in an address could be very useful separately. If you've got a name, a street address, a city, state, and a zip code, well, you may want to, look at everybody that has a certain zip code. You may want to look at everybody that's in a certain state. You may want to sort or filter based on, those kind of information, that all of those pieces of information. So that's where, as I say, the data becomes more important. And of course, that means then you've got to be able to relate it. When you talk about a Word document, the data related to that Word document because it's in the Word document. If you're looking at an address, then you've got to be able to make sure that if you've got somewhere stored a city, a state, a zip code, a street address, and let's say a business name at that address, well, you've got to make sure that you've got a way to group those things. In the Word document, you just throw it all in the document. In databases, which, as we're going to see, typically throw those into a table, but then you still have ways that you want to be able to relate across other tables. When you get into the structure of a database, the different vendors that are out there, and there's hundreds, maybe thousands of vendors. There's the interesting thing that we learned back when we were doing, actually with IT for Recruiters, when we were talking, we got a database course there. It's floating around on the Developer Newer site somewhere. I'll probably try to add a link to it at some point. We went through and did some research and did sort of a crash course in databases. And one of the things that you find is over the last 5 and maybe even 10 years, there's like a top 5 or maybe 10 database vendors, and they have like 99% of the market share or something like that. So there's all these others, but they have it drops off very quick once you get past the top couple of vendors. And those are names that you're going to recognize because they are, behemoth businesses, because businesses run on databases. So it's names like IBM and Microsoft and Oracle. And then you get into a couple, you had like MySQL, but MySQL ended up getting bought by Oracle. You have Postgres, and they're probably one of the few that's out there. I don't think they're owned by anybody right now. But most of these guys, the little guys, do something really good, and then a bigger company will just snap them up and buy their whatever their special sauce is that they've put together to make their database do whatever it does. That's a game changer. And even among these big vendors, though, they use different terminology. So it can be a little bit confusing if you go from situation to situation. If you go from one vendor to another, they're going to use stuff a little different. And so I'm going to try to avoid the names, even though the names I'm going to use are adopted by some of these. Typically what you have in almost every case, there's a concept of a table, and it's got columns and rows. And the easiest way to think of this that everybody can relate to is a spreadsheet. You open a spreadsheet. If you think, especially now with if you open a workbook in Excel, which is their technical name, you'll see you've got those little tabs at the bottom. Well, your workbook is your file. The worksheets are those little tabs at the bottom. And then you could think of each worksheet essentially as a table because it's got columns and rows. And once you get into databases, they have the concepts of primary keys and foreign keys, indexes, and then constraints and triggers. And every database is a little different how they do these things. Some support different ways to do these, but for the most part, they're there. And to just give a crash course in these things, primary keys are the thing that makes a row distinct or unique. And it's usually just an ID of some sort, a unique ID within that table. So if I have a list of 3 addresses let's say, envision an Excel spreadsheet, and the first 3 rows are 3 addresses, and I've got, the columns are street, city, state, zip code. So I've got those 4 columns. Well, if I add a 5th column, which for each row, I just essentially row number 1, 2, and 3, those would be my primary keys, would be that row number. That's how I know which one I'm on. If I give you the sheet and I say, I want you to look at a specific address, I'm going to say, look at row 2. There in spreadsheet, it's easy because you have the row numbers right there. Those are essentially the primary keys. When you get into databases, that's not always the case. So sometimes a primary key would be something that is going to make a record unique, which may be like a social security number, an email address, a phone number. We'll talk about why that's not a good idea, but those may be primary keys. Foreign keys are ways that you relate data to another table. So for example, I would have, if I, personally, let's say I've got a cell phone and I've got a home phone. So I have 2 phone numbers that are related to me. And if I put those in let's say that Excel spreadsheet, I've got a list of names on the first sheet and I've got a list of phone numbers on the second sheet, then I would have to have some way to tie those phone numbers back to whoever owns them. So let's say I've got my 2 phone numbers on the second sheet. I may have, let's say I have my name, my first and last name tied, joined with each as a column by each of those phone numbers. Well, then that becomes the foreign key. I can take my name, and I can go look on the other sheet, and I can figure out, oh, that's whose phone numbers these are. And I can tie then those phone numbers to, let's say, my address that's on the first sheet. That's how foreign keys work. Indexes are just, just an index. It's like a table of contents. If you look at a table of contents, you can say in a book, it's going to be indexed probably by chapter. So you can go in chapter 1, chapter 2, chapter 3, and you can look at it and say, oh, I want to jump to chapter 3. It starts on page 78. And so, boom, I can jump to say page 78. That's how an index works in a database, is it's just ways to quickly jump to certain records. And again, you can we covered it a little bit more deeply in our overview class. I don't want to get too deep into that today, so we'll leave it at that. Constraints and triggers are ways to limit how you put data in, or things that happen when you put certain types of data in. And an Excel spreadsheet, you may have seen somewhere, depending on the value that you put in, like let's say if you put a positive number in, it has a black background. If you put a negative number in, it turns it red. Those would be, essentially those would be triggers based off of, whatever value you put in, something else happens. A constraint is basically like if you've got a field that's, and again, if you have a type of, in Excel, if you have a type of a cell, maybe your type is number instead of text, then it's going to say, if you try to put ABC in it, it's going to say, hey, that's invalid. You can't do it. That's not a correct format for the value. So that would be a constraint. And the reason that you have these things in a database is so that your data doesn't get junky, so that people putting stuff in, you've got some control of the type of data they put in. So for example, phone numbers, if you want to be able to really retrieve them and manipulate them and report on them, then you want them to have a consistent look. It's really hard to look at a list of phone numbers where some are just 10 digits, some have hyphens, some have dots, some have parentheses around the area code, and then they've got a hyphen, some have spaces. It's just, even for you to look at it, it becomes annoying. And for a database to be able to program against that data makes it even worse. So you want to have stuff that follows certain rules because it allows you to make assumptions and allows you to speed up the saving and the retrieval of data. Columns are really, those are like your data types. That helps define what it is that you are capturing. And you think about it in a typical Excel spreadsheet, we use columns. There's going to be a label for our column. So if we have our little address spreadsheet, we're going to have name, street address, city, state, zip. Those are going to be 5 columns that are going to be on our spreadsheet, so that somebody looking at it says, oh, that's where I put a name, that's where I put the street address, that's a zip code, that's a zip code, that's a street or a state, and a city. I can't even remember how to use an address now. But you put those things together, and now you've got a table, but that column really tells you what kind of data is being stored in that table or that worksheet. In a database, columns they're going to have a type, so it's going to be similar to what they have in cells in Excel. It may be text, it may be numbers, it may be dates, times, binary. It may be, there's a whole bunch of different types that are potentially supported. It's going to have a size typically, because you're going to you're going to say, hey, I want somebody to put a 50-digit phone number in, because there's no reason for that. There's going to be let's say a 10-digit number, or if you have international, then it's going to be whatever it is, 12-digit, 13-digit, whatever it is for an international. You're going to have a name, so it's something that a human can look at it and say, oh, this is the type of data that I'm capturing. And it may even have a default value. So you may say, hey, if they don't enter anything, then I'm going to default it to something. This is often going to be the case when you're doing some, you've got some data that some high percentage of the time is going to have a certain value. So for example, if I say, if you want to push a certain kind of behavior. So if I'm doing a registration, and let's say I'm doing a registration program for drivers, and I've got a little, one of the options is, do you want to be an organ donor? Well, because of HIPAA regulations and stuff like that, I probably have to default that as no. But if I wanted to push that for a lot of people, I default it to yeah. So if you don't say, I'm going to assume you are unless you say otherwise. So there's some ways that you can impact behavior, but most often what you want to do is just make it easiest for your user to enter their data. And of course, then moving to the rows are defined by the column. A row really makes no sense unless you look at the columns, because that tells you what the data is and where it exists. But the data itself is actually stored in the row. So columns define the data, rows store the data. And we see this in spreadsheets all the time. So here would be, we've used this spreadsheet example, but now jumping to an actual database design, here's just a this entity relationship diagram for a database. I want to show you some things here. So if you think of each of these little yellow boxes as a worksheet, potentially in an Excel spreadsheet, that's what these are. Each of these is a table. If you see the top little rectangular section at the top of each yellow one is a title, so it's the name of the table. And then as you see, there's two columns going down, and on the left side of the columns is going to be a column name within that database and within that table, and on the right side is the type of that data. And so we're not seeing data here, we're just seeing the definition of the data. And then you can see at the bottom of this, there's a whole bunch of yellow boxes that have nothing else around them. So those are just standalone little tables. But then if you look up in the sort of that whole top left 75% of it, you see all these lines going back and forth. And those are relations across data. So there's things there that you have like a user, and there's a whole bunch of stuff that relates back to them, and it's user data, whether it's an address or certain properties or actions or files that are related to them within this design. So it can be very simple, like we talked about with our little address, 3-line address definition in a spreadsheet, or it can get very complicated very fast, which is not uncommon for people to start with a spreadsheet and then it starts getting complicated and they say, okay, now I got to go to a database. So now we've got like the 5-minute tour of what is a database. So now let's talk about actually designing it. Let's get into what we want to do. We've got this software project and we know we want to store and retrieve data. Well, how do we actually design a database? Well, the first thing we want to do is look at the core data that you want to capture. These are going to end up being tables, maybe multiples, maybe one table, maybe multiples. In our case, think about, we've got goals, so we've got that's one of our core data pieces. We've got users, that's a core data piece, and we probably have something that's core or close to it, which is basically work on a goal or progress on a goal. So those three things really are the core of this goal tracking application. And we can probably get more to it, but we'll stick with that for now. And then your next step is you want to consider reference and lookup data. So for example, in an address, one of your reference data would be a list of states. You're gonna want to have the ability to limit states that are in there to valid states. You don't want them to put LL as a 2-digit state code, and because it doesn't exist. You're going to want to give them, potentially even in the interface, when you think about it from that point of view, you want to give them a drop down of their viable selections. So you're going to use that a lot to get your reference and lookup table. With our examples, if we've got a user, goals, and work progress, well, we may have types of users. We may have gender of users, or genders if you want to get into all the different things you can do there. You may want to have roles. So if you want to eventually get to the point where your goals can be shared with other people, then maybe you're like an editor. Maybe you have like an edit, read only, an administrator, or something like that. You have different roles. With goals, you're probably going to have types of goals. We've already talked about having annual versus quarterly versus monthly. So maybe you have like a date type or a span of a goal. Those would potentially be lookups. And when you look at work, you may have some like sources. So maybe work is done by me or done by a third party. You may have like time frames. You may have estimates that are, and of course with your estimates, you may have things like measurements on that. So you may put in one, but then you've got a list of measurements. It's 1 hour, 1 day, 1 week, 1 year. Those all would be your reference and your lookup data. Then you start thinking about the relationships among your data. So we already know that we have relationships we're going to have to build from users to goals, users to work, from work to goals, And then from those lookup tables, each of those are probably going to have a reference into, some core table is going to reference a lookup to some extent, to make sure that its values stay the same. So for example, a state, if you had let's say you've got users, in our case, we're going to have users and we're going to keep their address. Well, then we're going to have, since they're going to have states, we're going to have a lookup based on states. And so with the user table, it's going to refer to our lookup states table. And there's going to actually be a foreign key relationship there that is going to, within the database, keep us from putting invalid dates, two-character date codes, as a value in our user record, our user's address record. If you try to do it, if you try to insert it, it's going to say, sorry, can't be done. It's not a valid value. So it means that no matter how we end up with the business rules implementing it, the database is going to protect itself from invalid or crappy data. Now, with the relationships, there's really three different types of relationships. There's one-to-one, one-to-many, and many-to-many. In a one-to-one relationship, you're usually not going to see that in a database because there's not, and we'll talk about that a little bit in best practices, there's just not always a lot of uses for it. But in a one-to-one, that means that if I've got two different tables, so let's say I've got an address table and a phone table. In a one-to-one relationship, that means that every time I have an address, I have a phone, and only one phone for that phone number for that address. And likewise, for every phone number, I only have one address for that phone number. And if you think of billing information for your cell phone, that's how that works. There's only one billing address, and your billing address probably, unless you have a lot of kids or something like that, your billing address has only one phone number, and of course your phone number has only one billing address because that's where they send the bills. One-to-many is much more common. So again, an address. You may have a business address and you may have a home address. For your phone number, you may have a work phone, a home phone, and a cell phone. In those cases, the one is the person, you in this case, and the many would be you have multiple phone numbers. Now, your phone number is not many, each of those phone numbers only gets you. If somebody dials that phone number, they're going to get you. So that is the one you to many phone numbers. Many to many is less common, but does happen. And that would be a case of, for example, a home phone number. Is that where you've got a family there? Is that you have got, and each of them, they've got the home phone number, but each of them have a cell phone number as well. So a phone number may get you multiple people. Could get you anybody in the family, or maybe people are sharing a cell phone, so dialing that phone, you may get one person or the other. And of course, those people all could have multiple phone numbers where you could reach them. So, if I've got two different cell phones, and I share one with my wife and another one with my team at work, then either of those numbers may get me, but they may get somebody else. So that means that I have multiple phone numbers that I can get to, and of course, multiple phone numbers have multiple people. So that gives you your many to many. And when you get into that, you end up having to do, with one-to-one and one-to-many, you can do it with two tables. When you get to many, you basically have to use XREF tables, which means you have to use three tables to keep track of, really one table to just keep track of the references. And now in this sort of that wrapping up the designing our database, and once you've got your core, you got your reference stuff, your lookup, you've put some of your relationships together, then you want to consider any supporting tables that would be really just for convenience and reporting. Those tables that we showed in that little diagram where you had all those tables at the bottom that were just standalone, didn't have any lines drawn to them, those were almost probably all support tables and reporting. So it's just to store information that maybe isn't related to your core. In a case like this, I may, let's see, a good situation from our goal tracker application is that I've got my users and I've got my goals. Well, outside of that, I may have a mailing list of prospects that, prospective members, they're not users, they can't touch any of the goals or anything like that, but I'm just keeping some track of some information for them because I may use that with some of my reports. Or I may have, for example, let's say with all these users, I also have with registration, let's say that I also have billing. And so I would have that billing, I'd have sort of like a billing account information that would be tied to a user, but maybe I also have somewhere I've got just a list of vendors that I deal with for billing. So I don't really tie it into anything in particular because when I do like process, let's say I do financial processing at the end of the month, and I take all the members and I go, grab some information and I send it out to somewhere to, hit their bank account for a membership fee. Then maybe I've got just some extra information I'm holding out for there to do the processing. Data duplication and normalization. So normalization can get very geeky very fast, but at the most simplest, the way you normalize data in order to remove duplicate values. You probably you're almost always going to do some form of normalization within your data. And so by that, when you think of the one-to-many relationships, you could put all of those things in one table. So thinking back to our example with our spreadsheet, when I talked about having addresses and I had phone numbers, well, what I could do is I could put all of that on one worksheet. On each worksheet, I could have a name, an address, and a phone number. And then I could turn around and let's say for Rob, I've got 3 phone numbers. Well, I could do Rob, address, phone number 1, Rob, address, phone number 2, Rob, address, phone number 3. So I could get all of my information in one worksheet. But now I've duplicated that Rob and address 3 times. And so what normalization says is don't do that. It says do Rob and address once, and then you put your 3, like we did, you have your 3 phone numbers in a different situation, in a different place, and they refer back to that one copy of the data. And, obviously size matters in that sense because you're taking up more space to store your data, but also just maintenance. Because if Rob moves, and I've got that first approach, I've got to go change his address in 3 different places. Whereas otherwise, I change it in one, and all of the phone numbers pick up that change. And that's why some normalization is recommended for all non-reporting tables. And why I say non-reporting is that when you have things like data warehouses and huge reports that you want to do a lot of work with quickly, since there is a cost to splitting stuff out and having to traverse those relationships to retrieve the data, sometimes the best way to do it is just shove everything into one table because it's easier to do that do that in reporting. You can go too far. Now, generally, normalization is going to increase the ability to scale your database because it's going to use less space per record. And the flexibility because it allows you to relate stuff without having to essentially copy and paste stuff all over the place. But like I said, it reduces your time to look up and retrieve your data. You can go too far because you can say, if you go to the most advanced form of normalization, there is not a string anywhere that's used. So if my name is, which it is, my name is Rob, if there's another Rob, if there's Rob Jones, Rob Smith, and Rob Brown all in the same database, if you go far enough, you would say, well, those 3 Robs have the same first name. So instead of replicating Rob at that, I'm going to actually normalize that. And I'm just going to say the name, the first name Rob is actually a 1. And so I'm somewhere else going to have to go look up what that 1 is. Which as you can, I think you can probably even guess from that example, you can see where that gets pretty ridiculous pretty quickly. And it becomes very costly to have to traverse even within the database, even shuffling bits around. It becomes very time consuming to go track all that stuff down. So as you're building your core, ours is pretty simple. We've got goals and we've got users and maybe we've got financial accounts that we hold on. Really, we're holding on to that just for billing. but you may get a little more complicated. But in our case, I mean, that is our main actors or groups of data. So like, now you can get much more complicated. Normally with an application, you're going to have a user, you're going to have some sort of account information. You're probably going to have like a product or a service that you're tracking in some way, form, or fashion. And I'm thinking, yes, this is more like a retail database. Retail database is always going to have that. You're going to have users, you're going to have customers, you're going to have orders, you're going to have line items of that order, you're going to have products that that exist on those line items. So in a typical retail database, you're going to have customers, products, or services, depending on what you're selling, and similar data. Regardless of what you're dealing with, it seems like most databases are going to have users of some sort. They're going to have probably information around those users, maybe addresses, maybe email addresses, maybe departments or groups are going to have some sort of relation, like maybe a employee hierarchy and things like that. Again, it goes back to look at what you're dealing with. But if you go back to your use cases and you look at your primary actors and your primary use cases, if you look at each of those, your data will come out of that. If you see any use case that you don't have any data coming out of, then you probably need to look again, because that would mean then that use case actually stores no data, that it just lives on its own. It never stores anything. It never needs to be retrieved. So again, once you've put these together and you've got your core tables, go back and look at your use cases and make sure that makes sense, so that you should be able to have from your core and your relational tables and that you can look at any given use case and you can point to, when I take this step and I use this data, this is where it comes from, or this is where it goes to. That's going to help you essentially sort of smoke test your design. For your lookups and references, just to sort of reiterate those a little bit, they're also often a very simple structure. A state that we've talked about, it could be the long name and then the two-digit name, or the two-character, two-letter name of it. So TN and then Tennessee would be your two columns. For your lookup values, you may want to have a third that would be just a unique, just a unrelated number. So, if you do an alphabetical order of whatever it is, Alabama, I think is the first state, would be 1. And so you'd have 1 AL, Alabama, 2, what would be Alaska, or AK, Alaska, and so on. Usually it's 2 columns, and that makes it pretty easy. You may want to have a third, like in the case of a state. Statuses and stuff like that, a lot of times it's just a lot easier to just make it, so if the status is new, working, complete, then it would be 1 for new, 2 for working, and 3 for complete. And the simpler you keep those, the better, because it's just easier for code to process it. You have other cases where, like I said, where you can have more, you're probably going to have more than 2 columns. Like I said, the aforementioned states, countries, sometimes status values, if you want to do, particularly if you want to display like a short version of it and a long version of it, new would not be a status, but pending, maybe you would want it to be just P or pending, depending on how you were displaying it out. Customer types, you see that a lot, where the customer may be, like financial. They could be a financial customer, and they may you'll see somewhere where it'd be just an F or an FIN, as opposed to having to put the whole financial out. And it's just to keep things consistent from a reporting point of view. And then consider some other things that you may need to do with your data. So you may have to do like sort order. You may want to, maybe you never want to delete it, but you want to make it active or inactive so that you can effectively delete it. And sometimes, like I said, you want those short or long names or labels based on, for reporting purposes and such. When you're building out the relationships across your data, you're probably going to be thinking of it if you think of it in the way of something either is something, it has something, or it uses something. So in building the relationships, for our example, a user has goals. So I'm going to have a relationship there. If I have another table out there, let's say I have different tables for annual goals, quarterly goals, and monthly goals, then in each of those cases, annual is a goal, monthly is a goal, quarterly is a goal. So what I may have is maybe I've got like some core goal information, but maybe I have slightly different information that I track for an annual, a quarterly, and a monthly goal. So for example, maybe a quarterly goal never has a parent. It never has anything. It is a goal. It is a major goal. That's it. There's nothing that that it's built off of. But quarterly goals have an annual goal that they're tied to, and maybe monthly goals are tied to a quarterly goal. So in those cases, each of those is a goal, and you're going to use that to see, to determine that I've got to build some relationships there. Uses A would be like our phone thing. Is that a user account of Rob? I use a phone, so I may have a phone table separately, or I use an address that I'm going to have a relation from my user account to that address. It may be part of the table, but I may want to split that out. And again, particularly if I have a one-to-many relationship. So if I have multiple addresses, it may be that Rob uses these 3 addresses, so I'm going to have the relationship between users and addresses. And of course, normalize. Well, I guess not of course, but when you normalize data, that's going to create relationships. That's just how it goes. When you have everything in one table and you split it into it now not being all in one table, but having a second table, you have to have the relationship because you have to be able to refer back to the primary data. As I said, you generally want to avoid one-to-one tables unless you're doing sort of like an object-oriented, things being different classes or types of an object. And in this case, it would be normally where the data, you have like large groups of data that would be essentially empty in certain cases. So if you have an account, let's say you have users in a system, and let's talk about, as we've talked about in the past, David having the idea of doing like a course registration system for students. Well, your users in that case is you're going to have administrators, you're going to have educators, teachers and professors, and you're going to have students. Well, students are going to have, and if you think of each of those were in a user table, that you have all 3 of those exist in a single user table, you may want to have these separate one-to-one tables where a student would have some student information, which would be like a course schedule, maybe are they paid, what year, are they freshman, sophomore, what year are they, what's their credit hours. A professor would have something different because they're going to have classes that they've taught, where they are on their tenure track, stuff like that. Administrators may have something completely different. Maybe they've got HR designations or stuff like that. So your user table, you're not going to want to have all of that stuff in a user table, even though all of those users, all those people are users. You could put it all in, but that means for every student, all of the professor-related data would just be empty. And for all the professors, the student-related data would be empty. So in those cases, you may want to do a one-to-one. So you would have in the primary table, the user table, you maybe just have a type. And by that, it allows you to say, oh, I've got to go jump, like the type is student. I've got to go jump over this student table, and there's going to be some key there that ties it back to this record. And it also, and sometimes in reporting, it makes it easier that way because you could just pull everything from your user table to see the user information. Separately, you just pull stuff from the student table to see, lists of students. As I said before, one-to-many relationships, very common. They're probably the most common, I think, of stuff that I've found in the databases I've built and worked in. So it's not only just bias of me building one-to-manys, it seems to be the bias of a lot of people. That does change, I think, a little bit if you go into object-oriented databases and some different ways of viewing data. If you go to like data warehouses and star schemas and stuff like that, I think maybe you start seeing stuff a little differently, but I haven't explored that enough to be able to talk too intelligently on it. In my experience, seeing a lot of one-to-manys. And I've given a ton of examples of that, phone numbers, addresses, accounts, customer orders, stuff like that. Many-to-many typically is going to be groups of stuff. I gave an example earlier. Another one would be So if you have a security model if you're modeling security within a database, so you have users that have roles and permissions, then there's going to be groups, and of course people can belong in, often they're going to be able to belong to different groups. Groups are going to have different, have multiple people in them, so that's where you start getting your many to many relationships. They can get actually pretty complicated pretty quickly, but it's something you want to ask yourself early on. Part of your use cases and going through your stories is, do I have to have, and specifically, do I have to have this relationship? Does this data have to be maintained in a way that is many to many? Is it one to many, or is it really just one to one? And that is a question I ask every time I'm building a database. I end up having to ask whoever the subject matter expert is, or the core owner or key stakeholder, that kind of stuff. I'm gonna at some point have that conversation with them, or maybe even the end user, whoever it is that would know, and to say, hey, how's this data relate to each other? Your support tables, really, structures can just get really complex. Databases can become complex. When you're sitting there and you're modeling use cases and you've got 150, 200, 1,000 tables that are trying to keep track of all this stuff, sometimes putting those extra tables in for your supporting tables, and that it allows you to maintain stuff a little bit easier, maybe report on stuff, maybe tie stuff together that's very loosely related. Most often when you get into like reports, as we talked about, you're going to denormalize them if you put it all in one page. And you just think about that. If you've got the example we had, even with the 2 sheets, that means that to look up all the phone numbers for a certain person, you've got to look at 2 different pages. You've got to look at the page with the people, and you got to look at the page with the phone numbers. If you put all of that on one table, it's easier to work with it. So that's the cost. But if you've got multiple sources, if you've got multiple places you store data, and you have those duplicates, then, as we talked about, it's going to cost you more time. It's going to cost you more maintenance to make sure all of that stuff's in sync. So my 3 records of Rob, the Rob name repeated 3 times with 3 phone numbers. If I change my name to Bob, I've got to go in and change 3 records. So it's going to take me longer to do that. So you don't want to get too nuts with how you set stuff up. You want to keep it simple. You want to make it reasonable. You basically, the sort of rule of thumb is you don't want to have to go more than about 4 or 5 tables to get data for commonly retrieved records. So like for a user, if I've got a user that's logging in and I'm going to get their information, if I have to go across 10 tables to grab all of the information about that user, it's either a very complex system that I'm modeling, or I overdid it and I need to go back and look at some ways to simplify. And then sometimes, and if it's really a complex system, then maybe I do need to look at having like a data warehouse or reporting database or something like that does allow me the ability to get that data quickly if I need to get it without jumping to 10 different tables. And that we've touched on these, but now get into some of the best practices. These are the things that are, they're rules of thumb. It's some places are very strict. Some companies are going to be very strict in how they do stuff. They're going to, if you're building a database form or you're working in a database or extending a database, they're going to tell you these are the rules you have to follow. Some don't. Some are very fast and loose and say, hey, do what you want to. But these are the things that I think you want to do. If you can, you want to do them anyways, because it's going to save you heartaches and headaches. Avoid meaningful primary keys. I talked about that earlier, where you could key somebody off of their social security number or their phone number or their email address. The problem is every one of those things could change. So if for some reason that changes, that could potentially throw off everything else that you've done. So, like in our example, my name of Rob, and I've tied it to those 3 phone numbers. If I change my name, then I've got to go back over to the phone number sheet and I've got to change my name, change it back there. If my primary key is Rob, so if on the first sheet I say Rob and an address, on the second sheet I have Rob phone number 1, Rob 2, Rob 3. Well, if I change to Rob, that means I've got to go back to the second sheet and change Rob in each of those situations. If instead I have, like, say, a row number, let's say Rob is on row number 1. And so then on that second sheet, instead of it saying Rob, it just says 1 for each of those it says 1, phone number 1, phone number 2, 1, phone number 3. Then I know that, oh, I just go back to row number 1 and I can see it. I can change the name Rob, not only change it one place. With primary keys, that is huge. It makes so much sense to just have it generate a number. So just basically do a row number or something like that. And most databases are built to do this for you. It'll just build a number every time you add a record. It'll just increment the number. That's the best way to do it. Name your tables and columns in a human readable way. A lot of people like to use all kinds of little abbreviations and all kinds of stuff like that, and all these little things that it's a long column name, but they shorten it to, it's actually like the column name is a sentence and they shorten it to the capital, the first letter of each word in the sentence or something like that. That's just ridiculously painful. And from a maintenance point of view, even if you built it, if you're not in it all the time, it's easy to go back to it and say, what the heck was I thinking? What does that mean? What is that column? And you have to look at the data and you have to go back and look at notes or whatever. Keep it simple and keep them as human readable as possible. Keep the sizes as small as possible and reasonable. So if you're storing, like I said, if you're storing a phone number, don't put it in something that could be 100 characters long. There's no need for it. Keep it all, try to keep stuff as compact as possible. It saves you from databases growing bigger than they need to be. Avoid magic values. Your database, you should be able to look at it, look at the data, and be able to figure out what stuff is. And this a little bit has to do with normalization. So if I go in and I've got, let's say that I've got, I've got a ticketing system and I've got a status there. Well, if I store 1, 2, 3, 4, 5, depending on what the status is, that is meaningless to me as a human being. I have to be able to look up somewhere what are those statuses. Well, if I don't have that number, if I don't have a lookup table with those numbers there, let's say I've got it somewhere in the code. I've got something that knows that a 1 is new and a 2 is open and a 3 is canceled. That becomes a magic value because it's like I've got to know where to look to go figure out what that thing means. Avoid that. It should be pretty much self-explanatory. If you start looking into the data and understand the relationships, you should be able to see what everything means. Avoid columns that have more than one meaning. This is the most nightmarish thing to deal with. Some people, if you're in it all the time, you can deal. I see people do it all the time. But as soon as that person leaves or somebody else has to look at the database, it's a nightmare. And what I mean by this is there's columns that people do stuff where they'll say, well, like let's use that teacher and student example that I had. So let's say somebody decided that they wanted to put all the teachers and all the students into the one table. Well, in one case, they're going to have a column that is, let's just say, I don't even know what we'd call it. But let's say we have a column that for the teachers, the column is where their homeroom is where their office is. Well, it's where their office is. For the student, it's where their homeroom is. Let's say it's high school students. So depending on what that is, it has a different meaning based on whether that type of user is a teacher or student. Well, that means that to figure out what that column means, what that actually is telling you, you have to go look at another column in order to figure it out, because you got to figure out what type of user they are before you can figure out what that room means. And sometimes it gets much worse because people put stuff in there, like in one case, it'll be a phone number. In another case, it'll be a room name, or something like that. It'll be something where it's completely unrelated data, and they just put it in the same column because they say, well, I can store it here, and I'll just, as long as I know what the type is and I know what that data is. That becomes a nightmare to maintain. So include foreign keys when possible, which is the next step. Is so always have what you should be able to look at the lines that I showed you in that ER diagram and be able to look at data, and then following those lines, which are the foreign keys, which are those foreign key references, you should be able to follow them to the other tables and put the data together for a record. If you don't have them, then it becomes a lot harder because you can you'll look at it and you'll say, okay, I'm looking at this table and I think not all the data is here. So where else is this data? And then you have to go figure it out. And that can be really nasty. Avoid circular references. So don't have, since I said most of the stuff is one-to-many, if it becomes many-to-many, then that automatically can be a circular reference. But what you don't want is you don't want to have something where like a user has an order, and an order has a product, or an order has an invoice, and then an invoice has a user. Well, then you've gone back around in a circle to the user. You want to be able to have it follow through. Now, it can be from convenience. You may want to do that, but I would do that in like a support table or something like that. Don't have it so that if you think of those lines that are going through all those tables, you should not be able to start following a path and end up back where you started, because it becomes confusing quickly. And it's an easy way to get really messed up report data, because you'll see duplicates of stuff because you'll have stuff walk that path one too many times. Excuse me. Simplify and normalize wherever you can to save space, but like everything else, in moderation. You don't want to have too many joins of tables to retrieve your data. It becomes very expensive in time. Bottom line, going through when you're putting your database together, work from your major actors and use cases. Add details as needed, properties and configuration information around those major objects and major actors and use cases. Review that for your relationships, do some normalization if it makes sense. Anyways, as you're looking at your data, that it's like, hey, we can simplify the way to maintain this and reduce the amount of data that we're having to store, and follow the best practices. I mean, it's really not that complicated. It is a bit of a dark art in a sense after that, because once you do it a couple times, you learn, and it becomes something that there is a bit of an art to it, but it's got enough of a science that if you follow these steps, you're going to do pretty good on your database. And then you can always refine it as you go along. That does it for the database. If you got any questions, comments, requests, anything like that, as always, shoot something to info@developernoir.com, or you hit the contact form on the site. At this point, we ended up going through a long question and answer session. We will not bore you with that at this point. However, I do want to mention that we have an ebook of a databases overview. It shows careers, terminology, and just a lot of general things you might want to learn about databases. Check that out on developernoir.com. And I want to thank you for your time, and thank you for listening. Talk to you next time.